Okay, Assalamualaikum warahmatullahi wabarakatuh. So today's topic is instrument landing system. Okay, under visual flight rule, or we call it VFR, without any indication from instrument as to the aircraft position relative to the desired approach path, the pilot must have at least 3 miles horizontal visibility with a ceiling not less than 1,000 feet to safely land the aircraft. Otherwise, he can use the instrument landing system. So instrument landing system is considered as IFR, or we call it instrument flight rule, in which we not required to land the aircraft by visual. So under ILS, there are two main guidance provided. Normally lateral, or we call it localizer guidance, and also vertical guidance, or we call it glide slope. Okay. Under glide slope ground station, okay, it will transmit signal to give aircraft descent path to the touchdown point on the runway, while the localizer ground station means the transmitter will transmit signal to give the aircraft lateral guidance to the runway center line. So as you can see here, this is the glide slope, the vertical guidance, while this one the lateral guidance. Okay, so the purpose of this glide slope is to guide the pilot so that aircraft land follow the glide path here, while here follow the lateral so that aircraft land at the center of the runway, not to left, not to right. Okay. So under localizer, actually we have 40 channel worldwide. Let's say we have KLIA one channel, and then Subang, ILS second channel, and each channel allocated at 50 kilohertz spacing. Let's say KLIA use 108.1. So the next station would be 108.150 megahertz, okay, because we have 50 kilohertz spacing. And this localizer normally shared its frequency with VOR, or very high omni range. However, this localizer use only the odd 10th megacycle count. For example here, 108.1. Okay. If VOR, the frequency should be 108.2, even number. So the difference is just the 10th megacycle. The odd one is for localizer. If this one become even, it's for VOR frequency. And this system radiate horizontally polarized. Okay. Carrier modulated by the tones of 90 Hz to the left and 150 Hz to the right. Okay. So this one you must remember which one to the left and which one to the right. If aircraft at the center, okay, both signal gets same strength from the transmit antenna, means if the aircraft at the center, 90 Hz equivalent to 150 Hz. Okay. So if aircraft to left, 90 Hz predominant. So the cost deviation indicator, or we call it HSI, the bar will guide the pilot to fly to the right. Same goes to when the aircraft at the right, 150 Hz is greater than 90 Hz. So cost deviation indicator, or HSI, will guide the pilot fly to the left. Okay, so this one is for glide slope. This glide slope system is paired with localizer frequency, means pilot need to tune the localizer frequency, but pilot don't need to tune the glide slope, because once the pilot tune the localizer frequency, it's automatically the system will select the glide slope frequency. That means by paired. So this glide slope has 40 frequencies, and the frequency band is 328.6 to 335.4 with 150 kilohertz spacing. So this system also has its tones, 90 Hz and 150 Hz. But 90 Hz normally for upper beam. So means if the aircraft higher or greater, fly greater than the glide path, means the 90 Hz is higher than 150 Hz. Okay? So as you can see here, if aircraft above 90 Hz is greater. Okay? However, if the aircraft is below 150 Hz is greater, not lesser, greater than 90 Hz signal. So when the aircraft is above glide slope path, okay, the indicator normally at the HSI will guide the pilot to fly down. Okay. This is the frequency pairing. Okay, let's say the pilot tune the localizer frequency. As I told you, localizer frequency, the odd 10th megacycle is being used. Odd, this one. 113, the odd 10th. Okay, so if pilot tune to this frequency, okay, the glide path or glide slope will be automatically selected. So this is the component required. So the main component is the navigation control panel. This is where the pilot tune frequency. Then we have the receiver, the one that we receive and process the signal from the localizer and also glide slope ground station. And this is the antenna. We call it VOR localizer antenna, located at the vertical on the top of the vertical stabilizer. This is another localizer antenna located in the nose radome and also the glide slope antenna. Okay. So this is the location of the receiver, while this one the location of the localizer. This is localizer and also the glide slope antenna. And we also have one more localizer antenna shared with VOR at the vertical stabilizer. So this is localizer and also glide slope. Okay. This is the actual picture. Okay. So again, this is the frequency tuner. This is the indicator. So here we have the glide slope. So normally this flag will be out of view during normal operation. Okay, so we can see here, if there's no flag here, there'll be a yellow bar here, a yellow arrow here that will guide. So normally our indicator will provide command to pilot. Okay? So means that if this arrow is below, means it command the pilot please fly down. So same goes to this type of indicator. So also have this indicator has indication for glide slope and also the localizer. This is ADI, this is HSI. Okay, so that's all the ILS topic. I hope that all of you will understand the concept of the localizer and also the glide slope.